For this lesson, we're going to be looking at Venn diagrams. These diagrams were named for John Venn, who conceived them around 1880. The two circles, A and B, represent sets within the universal set S. The universal set S contains everything within our diagram. Now, all of the items within these sets are called elements. And then where our two sets overlap, they have common elements. So these are all of the elements that set A and set B share. So for example here, if we let set A be the set of students on athletic council, that would encompass all the students who are in this circle here. And then if we let set B be all of the students on student council, then that would encompass all of the students here. Now the area where they overlap in the middle there represents students who fit into both councils. So students who are on both athletic council and both student council would be in the middle of the diagram here. Now our next definition is a subset. And a subset is a set that is completely within another set. So for example, A is going to represent the set of members of Canadian Parliament. So all of A here is our members of Canadian Parliament. And then fully within that set, we notice set C. And set C is the set of cabinet ministers. And all of these cabinet ministers are also members of Canadian Parliament, so all of them fit within that other set. Next, we're going to talk about our principle of inclusion or exclusion. So, my number in elements, or A or B, is equal to the number of elements in A plus the number of elements in B minus the number of elements in A and B. So, to give you an idea, this means the number of people in A or B. So, not shared. Just the people who are either just in A or just in B is equal to all of the people in A plus all of the people in B. And then we need to subtract the ones that are shared between them because we don't want to double count those. Now, if we want to write this symbolically, we don't use and or when we're writing this out. We use these symbols here. This U shape means or union. So it means I could be on athletic council or student council. This N or upside down U shape means and or intersection. So that means the ones that they share. So those would be the students who are on both athletic council and student council. So here's a picture to help you better understand that. So A union B looks like this. We have everybody who's on athletic council and everybody who's on student council and the people who are on both. We just need to make sure we subtract that middle bit because we don't want to double count, right? Because these people in the middle or on the dark pink area are all on both councils. So we just need to be mindful of double counting there. Now, this diagram shows you A union B, A intersect B. And that means A and B. So this only represents the students who are on both councils. So again, A union B is students who are on athletic or student council, which does encompass those students who are on both, but we have to make sure we don't double count them. And then A intersect B is A and B, so the students who are on both councils. Now, the easiest way to really understand this is to start doing some examples. So, we're going to answer the following. Now to start, we want to find the number of elements in S. This means the total number of elements in the universal set S. So how many elements total are in this diagram? So if I look at the diagram to the right here, we have 6 from A, 2 in A and B, 4 in just B, 5 in C, plus those 3 who fit into neither category. So that means there are 20 elements total. Next is the number of elements in A. So we have 6 elements that are just in A, but the elements that are shared between A and B still count as being elements within the set A. They just are also in B. But when we're looking at the number of elements in set A, we must include those shared ones as well. So 6 plus 2 equals 8. And again, I got those just from here, the 6 from this part of the circle, and then the 2 from this part of the circle over here. Next, how many elements are in A union B? So that is all of the elements in A and B. So we need to look at all of the elements that fit in both of these categories here. So we'll have 6 for the number of elements just in A, plus 4 for the number of elements just in B, plus 2 for the ones that they share, and that gives us 12 elements. Next is the number of elements in B intersect C. So we look at the diagram, and there's no area where B and C overlap. Because they don't cross, there's no elements that are shared. There's no elements that are in B and C. So that means there's 0, and it's because B and C do not overlap. There we go. Then we have the number of elements in A intersect B. So that is just the space that is shared between the two of them. So there are 2 elements that are shared between A and B. So this is a good example of how you can see how the diagram is really helpful in helping you to get a better understanding of which elements are in which set. Now let's try drawing one of these ourselves. So with a lot of these questions, drawing the actual diagram yourself can be very beneficial in understanding how many elements are in each set. So to start, the timetables of 75 students were compared. So we have 75 students total. Of those timetables, 48 students were enrolled in the data management course. 17 were enrolled in both data management and advanced functions. And 36 were enrolled in advanced functions. How many students are enrolled in neither data management or advanced functions? So let's draw our diagram. So we start by drawing just the box that goes around the outside. And then we want to think of the categories that we have in this group. So we're looking at students who are either in data management, in advanced functions, or neither. So we'll start by drawing a circle for data management. So this is for data management. And then we'll draw another circle for advanced functions. Don't mind how wonky my circles look. There we go. So now let's look at the information that we're given. So we're told that there are 48 students enrolled in data management, 17 were enrolled in both, and 36 enrolled in advanced functions. Now, when you go to draw these, you want to start with all of the overlapping pieces first. So we start with the pieces that are overlapping the most. So right now, that means these 17 students who are enrolled in both courses. Now, the reason why we have to do this part first is because now when we go to look at the students who are just in the data management course, we need to subtract these students who are in both because they are accounted for when we're counting the data management students. They are also accounted for when we're counting the advanced functions students. So we need to subtract those students who are taking both courses. So for our number of students in data management, we have the 48 students who are enrolled, but we need to subtract the students who are in both. So that gives us 31 students. Then for my number of students in advanced functions, there are 36 students enrolled. 17 are in both courses, so that gives me 19 students just in advanced functions. Now we need to figure out how many students have we not accounted for. So I think of how many elements are in my universal set. So there are 75 students total. So the students who are in neither class, my number of students in neither class would be 75 minus the students just in data management, minus the students just in advanced functions, minus the students registered in both classes, and that is 8. So we just put a little 8 out here. When I determine the number of elements in my universal set, it's important that all of my numbers on my diagram add up to that. So in this case, 31, 17, 19, 8 have to add up to 75, or I've made a mistake somewhere. So that does help you to get a better understanding if you've made any errors or not. Okay, let's try a little bit more challenging one, and we'll add another set. So a survey of 100 athletes was conducted. So this is important, 100 athletes. We'll start by highlighting that. The conclusion of the survey stated that 38 athletes played volleyball, 51 played basketball, 50 played hockey. The survey also stated that 20 athletes play volleyball and basketball, 14 athletes play volleyball and hockey, and 18 play basketball and hockey. 8 athletes play all 3 sports. Now we'll use a Venn diagram to determine how many athletes played none of the sports. So we start by drawing the rectangle. There we go. Actually, I'll make it a little bit bigger because we have 3 sets. Okay, so now I'll draw my sets. So I have this one here, which we can call the hockey one. It doesn't matter which one you make which one, as long as we put the right numbers in there. Here's the next one, and we'll call that the volleyball one. And then we have, let me make sure I overlap them enough. Then I have the basketball one. There we go. All right, so when we go to draw these diagrams, it's important that we start with the number of elements in our universal set if we have it. So we have 100 athletes. Then we want to start from the spot that has the most overlap first, and then work out from there. So we'll start with the number of students who play all 3 sports, because then we'll have to subtract those from the other numbers just to ensure we're not double counting. So we have 8 athletes playing all 3 sports. So we'll put that 8 right in the middle of all 3 sports. Then we'll look at the other overlaps or other intersections. So now we'll look at the students who play basketball and hockey. So I'm basically working my way through the question backwards, starting from the most overlap to the least. So 18 play basketball and hockey. So in order to figure out how many play basketball and hockey, we take that 18, so basketball and hockey, we take that 18 and we minus 8 from that because we only want the people who play basketball and hockey, not all three. Then we'll look at how many play volleyball and hockey. So my volleyball and hockey. From the question, it says 14 athletes play both, but we have to subtract those 8 in the middle. So that will give me 6. Then for volleyball and basketball, in the question, it says that 20 athletes play volleyball and basketball, so we need to subtract those 8, and we get 12. Now let's look at the students who only play one sport. So if I want to look at just hockey, in the question, it says that 50 athletes play hockey. So I need to subtract the hockey and volleyball, and subtract the hockey and basketball, and subtract the students who play all three. And that leaves me with 26 players. There we go. Next, we will do how many play basketball. So in the question, it says that 51 athletes play basketball. We'll subtract the number of students who play volleyball and basketball, subtract the number of students who play hockey and basketball, and subtract the students who play all three, and that will give us 21 students. Then, for volleyball, in the question, it says that 38 athletes play volleyball. Subtract those who play volleyball and hockey, subtract those who play volleyball and basketball, subtract those who play all three, and that gives us 12 volleyball players. Now the question wants us to know how many students play none of the sports. So, for neither sport, we're going to take our universal sample, so all of the athletes in our diagram, and subtract all of the numbers. So we have basketball and hockey, volleyball and hockey, volleyball and basketball, hockey, basketball, volleyball, and the students who play all three. And that gives us 5. So we need a little 5 out here. And that would be our number of students who don't play any of the sports.